Okay, now, what we have been doing so far, especially on the previous tutorials, we learned how to just use Bayesian regression models in order to model a multivariate regressions. We saw that we were able to model a response variable based on covariates, which is not only one. We have a multitude of the covariates or predictors in our model. Now, on the previous tutorial also, we talked about how to just obtain the credible intervals. And now the thing that we just want to do, we just want to just use the MCMC intervals in order to just based on the samples that we're just going to draw. Then in that case to see that, for example, to find the credible intervals and also the median of the response variable from our throws from the MCMC inside, I should say, the parameter space then. In order to do that, as you saw from the, I should say, the single variable regression, I'm just going to use MCMC. And I'm just going to go ahead with the intervals. And as you will see, it comes also in the package of the Bayes plot. Then it's good that if you haven't yet installed that package, please install the package Bayes plot, because the function that we're just going to use, MCMC intervals, comes within that package then. Okay. For the X, the thing that we need to just put inside the model that we have to use, essentially you can also press F1 here to just have the help menu to open to see what arguments do you need. For the X, as you will see, for the X, the thing that you have to use, it's going to be the model that you have just created, which it was model A. M, which stands for the multiple, I should say, regression. Then the other thing which I'm just going to do, I'm just going to come here to, for the parse, I'm just going to go ahead and create a combination of all the predictors that I just want to just find in my model. Then you remember that from the things that we did, the model that we created, essentially it had some covariates. And the covariates that we had, if I just scroll up from the console that I have here, you see that we had the murder, population, income, illiteracy, and the area. For the parse, which I'm just going to have here, I'm just going to go ahead and just type just the predictors variables which I have, which is going to be the population. Let me just go to just put that inside the quotation mark. Population. And also the other thing which I have is going to be the income from the model. The other thing which I have is the illiteracy. And lastly, I have the area in the model which I had. And also, what other things there? I just put that into my, I should say, model. I do not use the transformation. And I have the probabilities. The thicker line is going to be the 50% credible line. And also the outer probe is going to be 90%. And it comes, I should say, with the median in my model. Then it seems that we should be totally fine. And we are ready to execute this line. And in order to execute that, I'm just going to press Control-Enter to execute this line. And it takes a couple of seconds before it just gets processed. And you will see that the thing that I just have here, it comes with this, the plot which I have here. Okay, there it is. You see that based on the model that we had for the median in the inference which I had for the slopes of the median, for the slopes of the area and income and population, it seemed that we had the slope of the 0, which it means that we can exclude them from the models that we had. And also you see that for the slope for our literacy, I have this one, which is somewhere standing between 3 and 4, and I have, I should say, 50% of the credible intervals within, I should say, the thick blue, and the 90% with the less thick blue. And I'm just going to come also to just run the model which I had here for the summary of the model A and the multiple regression. And you see that when we just run that model, we had for the medians, you see that for the medians, For the intercepts, we had 4.1. That's totally reasonable. For the illiteracy, we had 3.7. And for the population, and for the income, and also for the area, we had this slope is going to be 0. And essentially, that's a kind of an indication that these features which I have in my model, they do not contribute to the prediction of, I should say, the murder rates in the United States that I'm just considering in my model. Then you see that, for example, also you can see the same thing graphically, that for the area, income, and population, I have as you can see, the slope is going to be 0. But however, for the illiteracy, I have the slope of 3.7. And essentially, it shows that where is the median is standing. And also, you can see the 50% of the credible interval. And also, you can see that, I should say, also the outer layer shows a 90% credible interval. I'm just going to go back again to the things that we have done in our previous models. That one we talked about, I should say, I'm going to go back a little bit further. And the things that we talked about that when we talked our models, then you saw that, for example, when we talked about the credible interval, we had the posterior interval functions that we had it before. I'm just going to do the same thing, and I'm just going to come here and write the posterior interval to see that if we get the same results. And I'm just going to write the credible interval. Then I'm just going to call the function posterior interval in the R stand arm. And if you wonder what objects you have to just put inside that functions, you're just going to press F1. You see that you're looking for the posterior uncertainty interval, which comes in the package R stand arm. And I'm just going to click on this to open the help menu there. And you see that the arguments that you have to just put, first of all, is going to be your object, which is going to be the model A, M. And also the other object which I need to use is going to show the probability. I'm just going to show the probability. Let's say probability is going to be 0.5. I'm looking for the thick line on my MCMC interval, which I'm looking for. And also you can see that we can just go ahead with the type. The central is a default one. And for the parse, you can go ahead with, let's say, with the illiteracy that we had, and it seems that the code is ready to be executed. I press Control Enter and I get that interval from here. You see that I have 50%. I'm just going to also graphically visualize that plot which I had there, and you see that the 50%, if you press F1, you see that the probability, which it comes with the thick blue line, is 50%. And if you just go to check in the plots, you will see that the plots that we have with the 50%, it shows the interval which is highlighted by a thick blue line. And if you take a look carefully, you see that I was able to precisely make an inference about how much is that interval by running the code as a posterior interval, which it shows that the probability that our parameter falls into that interval, and the parameter is going to be the slope that we had there for the illiteracy in our linear models. There, we see that if I execute that line, I have the interval, which is going to be 50% interval, is going to be between 3.2 and 4.1, and essentially you see that on the plot, it's roughly, you can see that this plot is executed there. And also, you can just go ahead with the probability 90%, then you see that. The less thick blue line, it shows that this is going to be between 2.54 to 4.8, and essentially that's going to be the same thing on the less thicker line that we're going to see. However, you can come over here and show that as a combination of illiteracy, and let's include, for example, some other variables. For example, I'm just going to include, for example, population. I'm going to also include the income, and also I'm just going to include, let's say, the area in my model. I'm just going to execute the line, and you will see that although for the population, income, and area, the last three ones, which I do have, I should say, a zero slope for the interval, but I have, I should say, a tiny something which comes with the power 10 to the power minus 4, something which is going to be incredibly small, and that small you do not see it here because it comes with the slope of the 0. Then as a result, you will see that the credible interval for this one is almost not easy to see that in the model then. Okay, in order to wrap up the tutorials that we had today, we were able, for a multi-linear regression within the Bayesian context, we run the model and also find the credible intervals for the features of our interest. And we saw that based on that, graphically, we saw that the only thing which is going to be tangible for us is going to be the illiteracy, which we can see that graphically, the 50% credible interval and 90% credible interval, it's shown graphically. And also the thing which we just flash back to our previous lectures, we were able to precisely get these intervals by running the model and the functions of the posterior interval, which is a function in the R stand arm, to just get the value which is going to be our credible interval. And we can select it by, let's say, the probes of 0.5 or the probability of 0.9 in order to just match the precise value of these credible intervals that we were able to just get that from the MCMC intervals functions within the Bayesian plot then. Okay, on the next tutorials, we are just going to do some more, I should say, graphical representations of our inference in order to just do some kind of techniques for the model selection then. Until next tutorial, I see you then.